So welcome, this is video number 6 of the ZiptieAI video series. In the previous 3 videos, I talked about how I built an FPV drone, then built and flew a Pixhawk drone, and then added AI to the Pixhawk drone. So that was the main part here. Those were the 3 epics that were in the getting into the air ASAP. That's kind of like the core thing that I wanted to accomplish when I first started doing the drone stuff. But once you get through that, then you start getting into epic 4, which is what this video is about. And epic 4 was really, when I started in late 2023, I was really interested in getting to know AI. And I heard about copters. I was in Ukraine, heard about copters, and this is really interesting. And I thought the copters would be a relatively simple thing. I just learned how to fly a copter, and then after that I would, zip tie on the AI and away we go. So I'd never planned to spend a lot of time on the copters themselves. But the copters weren't that simple. But at this point, you've got some basic copter knowledge. Oh, by the way, when you look at this, the numbering here, you see the strange numbering, 9, 11, 12, 13, 10, 14, 14B. These kind of numbering happens when I move things around. So I'm really big on numbering things. For one thing, when you're doing copters, every little detail is important. So it's really difficult following. One of the big difficulties I've had with tutorials is they're usually not numbered. And you leave out some small thing that you need to do. So I'm very big on numbers. But I do this manually in wiki. And so you see this number 1 here. Originally, this simulation here, software in loop simulation, this is the first thing I did at the end of 2023. It took me a month or a couple months. It was really complicated. But this is total simulation. And I thought this is what you needed to do first. And it turns out that what you do in this simulation here, it's interesting. But it's really not that important. It's really not that practical. So it ended up, it used to be number 1, and now it's like video 13, But I haven't renumbered it because if I renumber it, then I have to go through all my files and change the numbering, so I'll do that later. So anyway, this epic is what I call advanced AI. And there are 4 parts. The previous epics, there's really only 1 part in each epic. You just have an option of what kind of firmware you're going to be using. So are you going to be using, and then here in epic 3 it was which AI platform, Jetson Nano or Pi 5 you're going to be using. But here things are different. These 5 things is, first of all, you have what's called hardware in the loop. And hardware in the loop is a way of basically simulating the copter frame and the world that the copter is flying in. You use the actual Pixhawk. You test on the actual Pixhawk running whatever code you have on that Pixhawk, and everything else is simulated. Then you have Mavlink, which, well, let me go through this. Let me show this first, a picture of this. Here is the Pixhawk, and here is the simulation software. And here I made a diagram about this. And remember in the previous section why I made this HITL, epic number, why I made this come right after AI on the Pixhawk drone is because we had a problem. We need to test fly. We need to test software that is going to add AI to our copter, but we want to test it before we actually go out and fly, so the copter doesn't do something crazy and go flying off out of control, and then that would be a big deal, a big problem. So what you do is you do this hardware in the loop simulation where the world, the sensors, the frame is all simulated. I put together these diagrams. I've never seen a diagram like this before. And then you have your flight controller and a real flight controller and your real AI hardware. Let's see if I got a better picture of this. These kind of complicated diagrams. Anyway, that way you can test. If you do things that way, then in this part 9, you can test this AI software safely. So that's the first part in this advanced AI. The next one is called what I call the flight controller firmware APIs. And I'm really not sure about what I'm saying here is correct, but I think it's correct. Basically, this is from the brilliant genius who put together this software in a loop tutorial about 5 years ago. Some young guy who was running his own website called Intelligent Quads. He put together this diagram, and I added a few things to the diagram. And this talks about drone programming libraries. But basically what it is, you've got your flight control unit, and you've got like what I call a Mavlink API server. And what this does is this module inside the flight control unit in ArduPilot PX4 is it can accept commands, simple text messages via the Mavlink protocol. It can accept them from the companion computer or from a ground control computer. And you could instruct the flight control unit how to fly the copter. You could say, go to this location, GPS location, land. You say, just hold in the air. You give commands like that to the copter. And on the companion computer, the ground control computer, you have these different APIs that you can use: MavROS, PyMavlink, DroneKit, MavSDK. And you can, for example, with PyMavlink, Python Mavlink, you write a Python program. That's what I did for the first AI example. And on the companion computer, and then that will take care of all the messaging. And that will send a Mavlink command to this Mavlink API server. And then that's how you tell the computer to land. So after learning HITL, I think this is what you need to learn to find out all the different APIs, or whatever you want to call these, that you can use to control the computer. And then you notice one of these is called MavROS. And that brings us to the next thing. ROS. Okay, ROS is a way, a robot operating system. What this basically is you've got a ROS server running on the companion computer. And then you've got nodes. A node might be like a camera or the LiDAR or something like that. And this allows standard ROS messaging between devices. Now, it's kind of complicated to explain, but what's good about this is normally when you add a camera, like I chose the 920S camera before because it's USB, but when you add a camera, you've got to worry about the drivers for the camera. You got to worry about the physical connection. What kind of connection? I had a USB connection. And so when you write the Python program, you have to be careful to actually specify the port for that USB connection. And that was a real problem because there's two of them. Anyway, it becomes a mess when you have this. When you have ROS, then every device is basically agrees to talk the ROS protocol or whatever to send messages back and forth. And it is a much, much simpler way to do things. However, it's not simple to set up. But anyway, this ROS is the next thing to learn for advanced AI. This is probably how you really want to do the messaging on the computer. And then we have the next part, which is companion computer AI. Okay, so here I've got all these listed. What I did in Epic 3 with this J Nano, I used a Jetson Nano as the AI companion computer. And so this part right here, and I used Mavlink. This part right here is talking about showing AI examples. Here the real focus is on AI examples for each of the AI platforms. Like here is for just a Ubuntu computer. You could actually have a Ubuntu computer that connects to your drone via a telemetry wireless connection. And you could actually run that as your companion computer and send commands to the Pixhawk. I don't really think that's a good idea because one of the goals I always had with the AI was is having an intelligent copter so that if something happened with the connection, if the operator lost connection with the copter could take appropriate action to either fulfill the mission or come back safely. But if you have this running on Ubuntu and you lose a connection, then your copter has no AI. And then you have the Pi 5, the Pi 4, and what I used was a Jetson Nano, which was, I showed in an example. Then you have the STM. STM is the actual company that makes these processors that are the core of the Pixhawk and the FPV. And STM has a bunch of tools, and they have their own AI routines. And so I document what I explored within the AI routines for STM. And then there's AI study. And what this is some very, very large files I was working on in the fall of 2023. Before I got into the copters, I was exploring AI and quantum computing demos. And these are the files where I went through, did the demos, and I put my notes in here. And you notice that this machine learning, this one file here is 150 megabytes. There's a lot of screenshots. But that was the main one I focused on. That was from a young Norwegian genius, AI genius. And there were about 80 different demos that I was able to complete. And I spent probably a month or two on this. So here, this AI study here is not really on a companion computer, but I put it in here to give an idea of the AI technology that's available. And the core thing about AI is that AI is really complicated. Understanding how this actually works is really, really rocket science. But the APIs, the actual interface that you use to run the AI, that's all you need to know. And these are done pretty well. And that's why, strangely enough, I didn't spend a lot of time on the AI when trying to do an AI drone. I spent a lot of time on these open source drones, the drone software, which was not that well done in a lot of places. And that's where I spent most of my time, which surprised me. So, and then like I said before, I just put it here at the end. This is a very interesting simulation from Intelligent Quads. It was a huge effort to get this running because he made the video about 5 years ago. I was using this about 8 months ago. And he made YouTube videos, and he had a GitHub with the code. But the details, it wasn't step by step. And that was the problem. If you go in here and look at the documents that I did, these are some pretty big documents. But hold on a second here. Waiting for my computer to show the table of contents here on the left. There we go. So you see what I did here is I numbered all of the steps involved. So this is running on Linux. And so there's about, what about 97 different steps, almost 100 different steps. And you have to be really careful to do all this in the exact order. But this goes through, and it's really interesting. A lot of it, I think, is kind of outdated technology now. But it's really interesting simulation. It's not simulation like what you did in FPV simulators. That's where you're just simulating flying. This is actually getting these complicated simulation setups running. And this has like a really good physics package where you can actually design your own copter and then do realistic, like it would act in the actual real air testing of how this runs. The problem with all this is that it's not your copter, it's not your Speedy Bee F405, it's not your Pixhawk 6C. The problem with this to me is it's too far from reality. Now, if you had a big program where you're trying to test a new design of an airframe, you could take this simulation, go to a great deal of trouble to set up an airframe definition file, and then you could go in here and then test the aerodynamics of your new drone. But that's not what we're doing here. And so the original Intelligent Quads, although it's a really incredible tutorial, this is not what a person needs to know. But I left it in there anyway. So it's kind of a long video. But that's basically Epic 4, Advanced AI. There's a lot of stuff in here. Just getting started. But what I tried to do here is to give an organized conceptual presentation of the AI, and I really want to focus on this in the near future to get some really good AI explanations and the HITL and ROS and all that stuff. So that's it.